Water hyacinth has been a menace, hence causing havoc in the lake. It has made fishing and transportation impossible. Water hyacinth is the most recognizable and controversial floater. This affects aquatic lives within the lake. On the flip side of the coin, there is a brighter side of the plant compared to its darker side if managed correctly. Kisumu-based entrepreneurs have taken advantage of this problem and turned it into business opportunities. In Kibuye, at Kisumu Innovation Center of Kenya, we find artisans who have managed to create postcards, baskets, file holders, wine holders, trays, table mats, and furniture from this plant. These products are made from its stems, leaves, and fibers. The plant is manually collected in the lake by hand picking, since it's a floater, making it easy to be harvested.
I take the water hyacinths from the lake and then soak the dry leaves 3 to 4 days into the water, and then take recycled newsprints and soak them together. So they stay in the water for like 3 days, and then there are some improvised special tools which I use, like rods that I smash them with into some porridge form. So there are some improvised cubicle tools which I use to pour the milky substance, and then I put like some nylon on top of the board and spread the milky substance in that cubic perimeter walls. So they dry into some special paper which I use to make cards.
This form of artwork has not only beautified the county but also brought up the new tourist attraction sites, since these products are captivating. At Dunga Beach, creative innovators are using water hyacinth as raw material to produce biogas, which is eco-friendly. The plant is manually harvested by hand picking, then transported to the factory by trailers. It is put in the organic shredder, where it is shredded and moved into the Trex structure where decomposition takes place, leading to production of biogas.
After harvesting, we have our trailer which we put inside. We bring it to the platform. We shred, where we do shredding twice to remove the air elements. Then we also do slurification, that's addition of liquid, so that it can flow into the system. When that one is being done is when you have the adequate equipment, as in feedstock is ready for the process. Then you direct it into the system through the pipes. If you check up there, you see the 2 gray pipes for the 2 systems. Then those are the inlets for the system. After introduction there, then the biology begins, where we have anaerobic digestion. The first process in this manner is hydrolysis. At hydrolysis, the polymers, that is the food particles or the feedstock which has been fed, are being broken down into simple monomers or simple particles, the bacteria. Then it moves to the second process, which is acidogenesis. At acidogenesis, the simple monomers or the simple food particles are being converted to volatile fatty acids, where you get the bacteria is the one doing the work. Then it moves to the third stage, which is acetogenesis. At acetogenesis, the volatile fatty acids are converted to acetates, and hydrogen is also produced. Then it moves to the last stage, or the last process, which we call methanogenesis. At methanogenesis, the acetates are being converted into methane gas, which is CH4. And also we have the few traces of CO2, that's carbon dioxide, and few traces of hydrogen sulfide inside the system. Also we have the liquid, which is the bioslurry, which comes out the outlet, from the outlet that is. And the gas is being, as in we tap it in the balloons, those maroon balloons which are on top of the system, where we get the pipes directing them to the main or to the burner, depending on the system. But this one, we have a main pipe which connects to all the balloons on top of the system. Then from the main pipe, it goes to the pumps. The pumps are used to sucking. We'll be supplying more than 15 burners, so there should be continuity of the gas coming to the burners. And also in deep frying, they require a lot of gas, so the continuity is very important when you're doing deep frying. So from the pumps, it goes into the burner where you burn the CH4, that's like a methane gas. When you burn it, you get the two products, that is water and CO2. The water is getting evaporated because of the temperature around the burner, so you can't see the water, but it's being produced when you burn the CH4. Then it goes into the atmosphere. Then the CO2 also, a few amount of it, not much, you also get it settled in the environment.
The gas is locally supplied to women who fry fish along Dunga Beach. The biogas has made cooking to be faster, hence saving money and helping in preserving non-renewable sources of energy.
In order to make the project sustainable, of course, you've got to generate income. So we do have meters on all of the stoves. At the moment, one of the stoves is being used. The ladies come and say they want to use the stove, and they'll take the meter reading. They'll use the stove. We balance the pressure to make sure that they're getting a very efficient flame. And then when they're done cooking, they come and take their meter reading. So every cubic meter, they're paying 50 shillings, which is far less than what they would be spending if they were spending it on firewood.
The process of getting this organic fertilizer is cheaper because manufactured fertilizer is imported, hence saving importation costs. The production of this type of fertilizer is a source of job opportunity since the raw material and labor is required and readily available.
We meet the energy demand of Dunga Beach. We will be taking out about 3 to 4 tons of water hyacinth every day. Currently we're taking out just under 1, and we're meeting the demand of just the fisher ladies. If we're taking out 3 to 4 tons every day, and we replicate this model on all the other beaches, some beaches are much bigger than this. Homo Bay, Kendu Bay and all are much, much bigger than this. Luanyi, 10 times this easily. So if you take an average of 3 to 4 tons on all the beaches, you'd be taking out, 600 tons of water hyacinth every day. That in itself would greatly reduce that floating mass that is causing all of the havoc. So water hyacinth would then become a benefit. So because you're earning from it. So the best way to manage the water hyacinth is to turn it into a resource so that the local communities, everyone around the lake, will actually benefit from it. You can harvest water hyacinth, dry it, and then take it inland and sell it to farmers for animal feed, or sell it to people with biogas digesters to use as feedstock for their digesters. So it's full of different income streams and benefits to the local community. All of them in what's called, there's a term going around now, circular economies. There is no waste. Everything is recycled. What goes in comes out, but goes back in again in another form. So everything is going around. We're looking at the brokers who are bringing in the charcoal, for instance. What we will do with them is we will get them, they're brokers, they're used to brokering stuff. They can now broker the fertilizer back to the farmers instead of brokering charcoal and firewood into the women. So we're trying to adapt to the technology to meet, not to leave anybody out, not to create and not to put anybody out of work. Just change their mindsets, change their inputs, change their careers to a certain degree, and hopefully manage the water hyacinth. Combined with other technologies like the paper making, we want to combine ethanol making, because not everyone can have digesters, and biogas is a bit complicated to move, but bioethanol is easy to move. And then the The sludge from the ethanol production would then go into the digesters anyway, so we still have now a triple product coming out of that process. So combined with multiple different processes, people making furniture and what have you, we can very easily manage the water hyacinth without spending huge amounts of taxpayers' money, taking it out and dumping it somewhere where all it's going to do is pollute.